Hello, welcome to the series of Network Security Essentials. So in this session, we will see the first error detection method is a parity check. So this method is there in the data link here for detecting the single bit errors. So normally the parity check method is used to detect the errors, single bit errors in the message or data. So in a hash function, we are also using this method. Okay, so format is a very simple, that is m plus 1. M is nothing but the message or number of message bits in the data. Let's consider here I'm having 1010. These 4 bits. Okay, so to detect the single bits, we can use the parity checks method. And 1 is the parity value need to be added in the message for checking the errors. Okay, so parity check appends a single bit to 0 or 1 depending on the number of 1 bits in the input sequence. So formula is given here. If number of 1 is a even, then parity bit value is a 0. Means in my original message, how to add the 1 value on which condition. So if number is a 1 is even, so parity bit value is 0. If it is a odd, then parity bit value is a 1. So for example, here one example is given, 1010 is our original message. So in this particular message or data, how many ones are there? Two ones are there. Here is the first and here is the second. So two ones are there, means the number of ones is even. So parity bit value will be 0. So we will append 0 at the last. So this data will be sent to the receiver. So 1 bit parity check can detect the single bit errors or odd bit errors. Let's consider here one example. I'm having 110. This is my original data. Fine. So in this original data, how many ones are there? 3 ones are there. That means odd ones are there. So in appending the value, parity value, we are adding 1, right? So as it is mentioned here, if number of 1 is odd, in this case number 1 are odd, so that is why the parity value which is appended at last is a 1. So this data we are sending to the receiver. Now receiver will check, yeah, at last 1 is added, so he will check how many ones are there. 3 ones are there. That means the data is received correctly. So let's consider the same example. Due to any type of error, the first value from the original data is changed. Fine. So first value is changed. With this 0, I have just replaced 1 with 0, and this is the sent value to the receiver. Now receiver will check at the last 1 is there, but in my data 1 values are 2. That means even 1 values are there. So parity should be 0, but parity is 1. That means there is a error in the data. Some bit, any single bit has been missed or multiple bits have been missed, can be detected by the receiver. So remember that parity check is used for only detecting the single or odd bits. So sender is sending this value to the receiver. Okay, so at the receiver end, a receiver will check how many ones are there. No one is there, and only 0 values are there. And parity bit value is 1. So he will detect that there is no particular value, 1 value in the data. That means there is a error in the data. Okay, so he will check how many ones are there. No, anyone is there. So if no ones are there, and parity bit value is 1, so in that case he will check that there is a particular error in the data. So likewise, we can use parity check value for checking the odd bit errors as well. Okay, thank you.